few days ago, some of my friends on Facebook were actually remembering what their first computer program was. I seem to remember. I actually vividly remember my first computer program. It was called Submarine, and I wanted to tell the story about it. This was 1984. I was 9 years old, and my first computer was CZ 1500, which was an Argentinian clone of the Timex Sinclair 1500. The manual for this computer you see right here. Timex was a Portuguese company, and Sinclair was the iconic British company that actually created the ZX80, ZX81, the Spectrum, and all those very famous machines. This is the original manual of the 1500, and it was a 16K computer. I happen to have one such computer here. This was the original computer. It had a rubber keyboard. As I said, 16 kilobytes of RAM memory. It had a 9 VDC jack here, so that we actually didn't have switches. It was just, you turned it on by just plugging it in to the electrical outlet, right? So we had 2 jacks for the tape recorder and an RCA jack for the TV. In those times we didn't have monitors. It was just a regular TV, a cathode ray tube that was lying somewhere on your house. All right. So in 1984, there was a magazine that came out in Argentina called K64. There are efforts to actually put every single volume online, but I remember that my first computer program was in the first issue of that particular magazine, and this was, in fact, so luckily the computer, the magazine, the first issue of K64 is online. I will put the link below, and I could actually see this program again after probably 35 years or so. This was the Submarine program. Let me zoom in a little bit. So this was written for the TS-1000, which was the predecessor of the TS-1500. This had 2K of RAM, and the program was of class entertainment, I guess. And in the 80s, one of the interesting things is that we didn't have enough narrative power in the graphics and in memory to tell the story through the computer, so we made up stories in a way, and wrote them as parts of the program, but outside of it, right? This is pretty simple, but there were very complicated, complex, sophisticated stories. So in this case, it says you're on board of a warship and you will have to destroy an enemy submarine. To do so, drop bombs using the 0 key. Okay, and then you see the aesthetics are pretty simple but beautiful. There was a screenshot, which is pretty interesting, and here you see the boat, you see some sort of a bomb there, and the submarine. This is more or less like Space Invaders, I guess. There are interesting things to notice about this program in particular. Well, RAM are just remarks for some of you that still remember your BASIC. This was about 40 pages long. You had to copy it. You have to actually have someone, maybe, or if you were alone, you had to take more time to actually enter the code into the computer. I usually used my brother, and he used me to read, and so we alternated between reading and entering the program. Interesting things here to notice is that the lines jump in multiples of 10, right? So although you used to, the usual thing to do would be actually to design your program outside of the computer itself and then code it. Sometimes you actually forgot some line and you have to put it in after the fact, after that you had designed the program. And you're not human compilers, so you didn't know until you actually entered the program that you were missing something. In this case, probably the author had forgotten to say something about something between lines 40 and 50, and he decided, or she decided, to put a 45 there. Another interesting thing about this program is that in these computers, memory was the most important thing, and then we sacrificed computing power to get a little bit more space. For example, here this SC, the LED was the assignment operator in BASIC. So here, for example, SC would be is equal to not pi. Not pi, since pi would be a different number from 0, then not pi would be a 0. Okay, this was important because pi would be a float, but any kind of literal would actually take a lot of memory. It would take the visual representation itself. It would take so 1 byte to denote whether it was to encode whether it was a float or not, and 5 bytes to actually encode the value, the floating point value. However, all the instructions of the TS 1500 and the Sinclair computers were 2 bytes. So in this case, SC would be equal to 0 using 2 bytes instead of the 7 bytes more or less that would actually that a literal would take. Okay. In this case, for example, L would be equal to 3 because that's the integer part of pi. So there were a lot of these kinds of tricks to save memory. This was, of course, at the cost of processing power. Actually, these had to be calculated in a way, but at the same time, it was better to save memory than to save processing power. Another interesting thing, for example, is that the graphics would be coded into the program itself. So in this case, this line 65 is telling the computer to print this thing at a specified screen point. So it would print this at 1 and 7 column versus row, and this is the boat, this is the submarine, and this is what you would this is the input key that you have to press to do something. Okay, in this case, in key would be input. If the key 0 is pressed, do something, right? Another thing that they would actually do is they would save. I mean, BASIC did have some sort of goes up keyword, but it would usually take a lot of space. So go-to was actually used a lot in these kinds of programs because they would be. It's easier to jump to an address than it is to encode subroutines and put go sub and return and stuff like that. But the computer did have a stack in a way, so it could have been done. The objective of this screencast was not for me to talk about it, but what I want to do is to transmit the experience of coding these kinds of programs into these very old computers and make these bytes come to life again after 35 years, so that, for example, my children who've never seen anything like this would be able to understand the experience or what we did when I was young. So I'm gonna re-enter the submarine code into the 1500, and I'm gonna play it after, again, 35 years. So let's get on with it. I'm gonna start re-entering the submarine program from the K64 magazine, volume 1, issue 1. First thing I have to do is turn on the TV. No volume, I guess, because there's no need. It's just static. And then just to turn on the computer, I just have to plug it in. And that should be it. Yep, there's the key cursor. And I'm going to start writing the program as it was written a long time ago. Of course, you don't have to wait all this time, so I'm gonna just speed it up, and I'll see you after I've finished it. Alright, so I can't wait to actually press run on this thing and see what happens. This code ostensibly hasn't been run for many years. At least, I don't know if it's ever been run on this computer, probably not. So it has some sort of mysticism to it, if you will. Let's see what happens. So I guess I just have to press run here. Oh, yeah, okay, fine. The ship is actually... Oh, the bomb! No! I failed! Oh no! It's very slow, but it's still quite fun. Go! No! No! Okay, I think I have still one more life here. Okay, go now. Please explode! Oh yes! Oh yes! Let's see. This is not easy anyway. But let's see. Okay, go. No! Yes! No! I failed again. One more. Oh, I see. I have to actually... Oh no! Well, the keyboard is not particularly sensitive. So okay, one more. Go. Come on. No. Oh! Yes. No! I failed again. Game over. Score 1. Well, I sucked. In any case, it's pretty amazing that this thing had no actual errors. I might try to enter it again at some point in the future. Again, this is like 30 minutes of my life and that I really don't have, but space. I guess that's it. But at the same time, I mean, I want to show you how these games are recorded and or saved to the cassette player. And yeah, so there's one more thing I'd like to say about these programs, and that is this is like all good art. It's ephemeral, and these computers didn't have any way to easily record your work. So I'm just gonna delete everything by just unplugging the computer, and that's all it takes. So once I turn it off by unplugging it from here, my game will be deleted. It's kind of interesting, no? It's pretty. So here we go. Alright, so that's all for today. This is what it took 9-year-old me to actually play a game in the early 80s. Thanks.